All right, so here we go. Our aim for today is sigma notation. Well, we have two aims, but this is the first one. And so actually, it turns out problems like this are super easy. Super easy. And that's the theme for this class, that a lot of problems look real complicated. That looks like Greek, right? It is Greek. It is Greek. This symbol right here is the sigma symbol. It's the Greek letter for S, and it stands for sum. That's what we're going to do. So here's what you do. You basically start. Oh, come on, computer. You start here, and you plug I in, and then you eventually end here with this number right there. And what do I mean? I'll show you. Take a look. It's going to be 3 times 4 minus 2 plus 3 times, and you always use whole numbers, 5 minus 2 plus 3 times 6 minus 2 plus 3 times 7 minus 2. Yep, and that's where you stop. And so what happens is that instead of writing this out a bunch of times, mathematicians came up with this kind of, way of describing a particular set of numbers so that it was easier and more compact. You can also use computers to program. You can program them using this kind of notation, and it will just produce answers. You do. It's slightly difficult to try and use it. I can show you, but it's easier just to literally write it out like this. I'll teach you a shortcut here and there, but just write it out, and then 3 times 4 is 12, and 12 minus 2 is 10. 3 times 5 is 15, and 15 minus 2 is 13. 18 minus 2 is 16, and 21 minus 2 is 19. Right? It's arithmetic. Is it arithmetic? Yeah, it is arithmetic, because the difference between each one is 3. I think is it 58 or 56? There you go. That's it. Let's play again. And so there you go. There's the answer. You just plug the numbers 1 in to the formula, 2, 3, 4, 5, all the way up to here. Simplify it, add it up, 225. Yeah. Very nice, very nice. So we talked about this. We put it up on the board, and then we had people think about what it is that we were supposed to do. And it turns out this is the same thing as, AKA, it's the same thing as saying 2 times the sum of this. So all you have to do is find the sum, and then take your answer. Whoops. I don't like the J written like that, though. Find the sum, and then multiply it by 2. And we're going to do that right now. All right. So here we go. So as you can see, question number 3, we filled it out. We just plugged it in. We simplified it a bit more, simplified even further, and then multiplied it by 2. And that's how those problems work. Piece of cake. Let's do question number 4, just to practice it over one more time. So there you go. There you go. That's how to do question number 4, right? You just start at 2, go to 5, plug them in. Simplify it, multiply it by 3, and then you're done. That's it. It really is that simple. Doesn't get any harder. You just have to know about the placement. Yep. Well, this is on your test. This was one of the first questions. This was actually a part 3 question on the regions. And all you had to do was understand the Greek language being presented to you, plug in and show your work, and it was easy points. Let's play one more time. One more time. Notice now I move the number from the outside to the inside. It's very easy, very straightforward. Good luck. Videotape that. And so there were some questions about what do you do with this 4? The 4 is on the inside next to the sigma, so it goes in each term. And then all you're doing is subbing in for 1 for j each time. And now we're going to have to plug that into our calculator and find out what answer we get. So we had a discussion. There's lots of ways that you could plug it into your calculator. I just happened to plug it in this way. But there was, what, a little second entry we could use? What other suggestions? 1 at a time. That's fine. That's fine. At the end of the day, you're going to get 3.75 5, and that's our answer. Any questions? We're good? Good. What do you guys think? Easy? Oh my God, it's so easy. Okay. So now we're going to talk about arithmetic series, and we just talked about the story of the famous Gauss. It turns out the formula for the summation of an arithmetic series is the following. Sn. Guess what S stands for? Sum of n terms. The sum of the n terms of a particular sequence is equal to, remember the story I just told you about Gauss? What did Gauss do? He took the first term, and what did he add it to? The last term. And then he multiplied it by something. What was the something? The number, was it the number of terms? It was the number of pairs. So you take the number of terms and you divide them by 2, and that gives you the number of pairs that there are. And this is the formula for summing up any sequence series of numbers. So you don't have to imagine if you punched all these numbers into your calculator and then you found you missed one. Or you accidentally put in 47 instead of 46. Oh my God, I would freak out, wouldn't you? So here's what you do. How many terms are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 11 terms there. So we want the sum of 11 terms. That means that there is 11 divided by 2 pairs. The first term was 26 and the last term was 76. Which means that it's going to be 5.5 times, what's 26 plus 76? 102. And the answer is 561. And that's what we do. Piece of cake. So now we're on question number 2. This is the last question that we're going to be exploring today. And some people might say, but wait a minute, doesn't it have to be like adding to be arithmetic? Or as some other people have scolded me, arithmetic? Okay. We could rewrite this sequence like this. This is 5 plus -2 plus -9 plus -16, ... And so, what's up? What? Yeah, they do that sometimes. So let's first check to make sure it's arithmetic. What's the common difference? Ooh, it is arithmetic. Now find the sum of the first 10 terms. I mean, you gotta have the first 10 terms in order to find the sum. So let's try and build that out. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. 5, -2, -9, -16. What's after -6? -23, 37, negative what? 44, -51, -58. And then you could literally plug this into your calculator, but once again, that would be annoying, and you could mess up with the negatives. So let's use the formula, right? Let's find the sum. The sum of the first 10 terms of this sequence is equal to 10 divided by 2 because there's going to be 5 pairs. The first term of our sequence was 5, and the last term was -58. And if you punch that into your calculator, I believe it is -265. And that's all I got for you for today.